want to extend it as far as you can because you don't know where that other line's going to be. Okay, so making a nice long line for yourself. Okay, go back to the other page. Let's graph our second one. So on the second one, again, it's already in slope-intercept form. What's my y-intercept? Anybody?
0, 1.
What's my slope?
4, 1.
I'm going to graph it. When I graph it, again, what was my y-intercept? Somebody?
0, 1.
What is my rise over run?
4, 1.
And again, I would give yourself several points. So continue up 4 over 1. And then remember, if you're running out of graph, you can come down 4 over 1. Now, look at this. Now, we know my lines are not good, but I can tell right now this should have gone through here. I can see my intersection is right here. Is your guys' lining up perfect?
Yeah.
Should be. Okay, so when I graph that one, mine would actually be shifted over a little bit if my dots were better. And then, so then my ordered pair is what? What ordered pair is that? Where do these come together?
-1, -3.
Okay, so -1, -3. That is your solution to that system. Is it making sense? Okay? Well, what happens, is everyone caught up with me?
Yeah.
Is there anyone that needs more time?
Wait, what is the solution?
The solution is the ordered pair -1, -3. So when you look at that, Nick, when you look up here, do you see that that's where these two come together? Okay? That's how you know what the solution is, because this point right here is a point on this line and it's a point on this line. So that is a solution for both lines or for the whole system. Say it again.
Where they connect?
Where they connect, where they intersect. Okay? All right, still with me? Charlie, question?
On the first one, would it have been negative and -3 then?
Yes. My graphs just didn't come out nice. Yours should come out better than mine. Okay, go back to... Now, look at this. It says, when the graphs of two equations are parallel, there's no point of intersection. So wouldn't that... Think about that. Are parallel lines ever going to intersect? No. So, therefore, is there going to be a solution?
No.
No. Okay, so you're going to write no solutions. Now, let me save you some time. Think about two lines. What would be the same in two lines to make them parallel? So let's say my two lines look like this and they're parallel. Tell me about that line. What would be the same in those two lines? Travis? The slope. Wouldn't the slope and parallel lines be the same? Okay, so if I know that, do I even need to graph it? So look at number 3. Number 3, this one's in slope-intercept form already. This one is not. I'm going to get it into slope-intercept form. What do I need to do to get it into slope-intercept form? What do I need to isolate or get by itself? Y. How do I start that? What am I going to do, Jacob?
Minus 18x.
Okay, so first thing I'm going to get that 18x off of that side. And then remember, whatever I do to one side, I have to do to the other. So now I have 6y is equal to negative 18x plus 42. What's my next step going to be? What do I do after this? Casey, tell me. Okay, I'm going to divide by 6. And I'm going to divide this whole side by 6. Now remember what that means. So I'm coming over here. That means that negative 18x is divided by the 6 and the 42 is divided by the 6. So I end up with y is equal to what? What's negative 18x divided by 6? Jacob, tell me.
Negative 3.
And then don't forget your x. And then what's 42 divided by 6?
7.
Okay, so plus 7. Okay? Now look. Here's my slope. Here's my slope. Are they the same?
Yes.
So we know if they have the same slope, they are going to be what kind of lines?
Parallel.
Parallel lines. Are parallel lines ever going to intersect? So the answer is no solution. You do not even need to graph them. Now you may not recognize that, and you may go ahead and graph them, and you're going to see there's no intersection, and you're going to go, oh, I just wasted a bunch of time. So really look at those equations, your linear equations, before you start graphing. Okay? Okay, look at number 4. Number 4, again, I have two equations, or I have a system. They are not in slope-intercept form, so I need to get them into slope-intercept form. Okay, so to do that, this one here, I'm going to rewrite it. I have 27x plus 9y equals 36. Amanda, what am I going to do?
Minus 27x.
Perfect. This cancels. I have 9y equals, remember we're going to put that x term first, and then add that 36 on. They're on like terms. I can't put them together. What's my next step, Maddie? Josh, tell me. Okay, so divide by 9. Divide by 9. So remember again, I get y is equal to, that means the negative 27x is divided by 9, which gives me what? Anybody? What's negative 27 divided by 9?
-3.
Okay, so I get negative 3x. And then what's 36 divided by 9?
4.
So plus 4. It's now in slope-intercept form. This one's not in slope-intercept form, but it's pretty close. What do I need to do to it to make it in slope-intercept form? Chase, what do? What has to come first here? What always comes first in slope-intercept form when you're writing it? So you get y equals your x term. You're right. So I am going to switch this around to negative 3x, and then that's actually plus 4. Now look, what are you noticing about my two different equations? So here's one of them right here, and here's the other one. What can you tell me about them? They're the same. So is that not the same line then? So isn't every point a solution? Is that true? So do I need to graph this? No. So if you look back at your notes, where did those go? When the graph of two equations are the same line, all points on the line are solutions. And so you are going to label that infinitely many solutions. Lines never end. Every point's going to be a solution. So again, you don't need to graph it. You're just going to write infinitely many solutions. Okay? Again, make sure you don't waste your time, because what you're going to find is that you're going to forget, you're going to graph those, and you're going to end up wasting time when you really don't need to graph them. Questions? Okay, your homework's going to be to do 8-7 worksheet. We will do that on Friday. Thank you.